Okay, good afternoon. Just a minute ago, we were told that today, Jace and Steve-O told us that we're going to plot points in our calculator and find the line of best fit using our calculator. And we have an exercise set here to do that. So the first thing we're going to do is go and enter our points. So let's get out your calculator. And so I have a TI-84 CE calculator. And where do we go to plot our points?
Stat edit.
Stat edit. Okay, very good. So Luke was paying attention to the song. So I already have this data in here. To clear it out, I'm going to go up to L1, press clear, and then down arrow. And then I go to L2, go to clear, then down arrow. And if you don't have L1 and L2, because it's easy to just delete the column, I can show you how to set it back up. That's the setup editor. And what you'll do is you'll put the X and Y values in place here. So I want you to do that. On the left of the table, enter those values. On the right of the table, enter the pick photos kept. So we have photos taken. And you just go ahead and enter down here. And then after you've already done that, somebody help me do the rest of it here.
What are you
17, what's the next number?
128.
128? 140? 157?
110.
110?
188.
188?
And 170.
170?
Then on the other side it'll be 25.
Okay, 25?
31.
31?
39.
39?
52.
52?
21.
21?
45.
45? 52? Okay, so we have those. Now, one thing you're going to do is you're going to plot these points and view them properly. And to do that, you have to have some things set up right. Now, what I recommend when you set your window is, if at all possible, to have your X and Y axis included in your window. Why would you be interested in having your X and Y axis included in your window? Especially your Y axis. Why would you want to have your Y axis included in your window? What is an essential portion of a linear equation? A y-intercept, right? So the reason I like to do that, I like to be able to see that y-axis so we can actually see that y-intercept. Now sometimes you won't have it near, and you won't have the axes there every time, but that's what I recommend. Yeah, thank you, Emma, that's right. So right now, in setting a window, we look at what we have here, and if we're going to include the y-axis, what does the window have to be set at? This is the x values right here. The y-axis is x equals what? The y-axis is x equals what number? Zero, yes. So what I recommend is setting this to 0, the window from 0 all the way up to at least the highest number here. So what's the highest number here?
188.
188. So I recommend picking a number a little higher than 188, maybe 200, right? So we can go x 0 to 200, and then y, again,
60.
so you go up to 60, So 0 to 60. So 0 to 200 and 0 to 60. So I'm going to put this right here. It says, I'm going to put this right here. The window 0 to 200 by 0 to 60. Oh man, I'm just lost here. 0, comma 60. Okay, so now we go to our calculator, and where do we adjust our window? In window, right? So 0 to 200, and I recommend going up X scale maybe by 10, and then 0 to 60, and go up by, we can go up by 10 here also. Okay, is everybody to this point here? Now for the points to appear, we had the L1 and L2. Go to this Y equals key and make sure that your plot 1 is activated. So we go up here, press enter. So here's a window. Yeah. Yeah, and let me know if you have questions, or work with a neighbor. This is a good time for that. Okay? Is everybody good at this point?
Yes.
Okay, let's graph and see what we have here. Okay? Does this look like all the points are there? Now, are we going to see, when we graph a line through there, are we going to see the y-intercept? I don't think so, because the y-intercept is going to be way down here someplace, right? What kind of correlation is this? Reach back in your, what kind of correlation do you say? What kind of correlations are there? Reaching back into Algebra 1, ancient history of Algebra 1. One of the correlations that's very popular starts with a P. Another correlation that's popular starts with an N. Positive and negative correlation. Thank you. What kind of correlation is this? Positive because what? Now, if you look at the orientation, it looks like it's kind of upward, right? Is this going to be tight correlation or loose correlation? A little bit loose, but not, maybe a little bit of a loose correlation, so not perfect correlation. So anyway, so everybody's good to this point, right?
Yes.
Now, instead of doing yesterday like we did, remember we drew that line through there and used to predict? Now we're going to get the calculator to predict the line. Okay, where are we going to go to get the calculator to find the line for us? Stat.
Calculate them for.
Stat Calc 4. Okay? Stat Calc 4. So Stat Calc 4. And then what you'll do is you'll go down and press enter down here until you get to calculate. See that? And then press one more time and get your linear regression equation. Do you have that?
Yes.
Is anybody not here? Anybody not here? Okay, what I want you to do is write down your equation on your paper. So that's going to be y equals 0.3. And you don't have to write it out to a lot of decimal places either. You can just say y equals 0.33x minus 11. Or you can put minus 11.3. So y equals 0.33x minus 11.3. And then after you've written that down, you can come over here to your function editor, which is y equals. So here's where you enter that 0.33x minus 11.3.
Why'd you go 2 points past the decimal on the 33, but then not 2 points on the other?
Well, that's a good question. No, that was a really good question. Just kind of by experience, there was no really, I can't give you a real good answer for that. I could see that 0.3, because if I moved it up a hundredth, another hundredth, that wouldn't help that much. And this one, so I can't give you a real, I know the slope changes, the slope will change things over distance a lot more than y-intercept will. Okay, so that's one possible reason for it. But I kind of arbitrarily decided on those. So, but that was a good question. That was a defining question. But so I can't give you a real good answer better than that. Sorry, but that's a very good question. So now when we graph this, what are we going to see? We will see our line of best fit that the calculator figured out, but we did not, right? And then we can use our calculator here to, is there any question that's being asked? What is the question? Says, use a graphing calculator to create a scatter plot. We did that. Find a linear regression model and graph the model. We did that, right? Next, then use the model to predict the number of photos the photographer will keep if she takes how many? 150 photos. So where would we find such a thing?
If you go to second, which will bring it to you, second graph, which will bring it to your table.
So second graph will bring it to your table. Okay, very good. Let's do that. So if we go to second graph, now what I did here is I changed the table set here, because normally default your calculator is going to be like this, and then you would go to your table and you would see this thing, right? And so you could go down to 150, but what would be an easier way to get there? If we go to second window, so you can go ahead and just type in 150 here, right? So that's one way to do it. And so right here we have an answer, don't we? Let me show you another thing you can do. You can go to second window and go down here to ask and enter that, and then you go over to your table view, and then you can enter what you want. And in this mode, you could enter 0, find your y-intercept, right? Or, so that has a lot of flexibility as well. So what would be our answer for this to the question?
38.
So 38. So 38 photos. We are just about to go on to this B here, and before I turn you loose on that, does anybody have any questions on this part A? So you know, everybody knows what to do. So I'll turn you loose on part B, and that'll be it, okay? Yes, Luke.
I just need some help with this.
Okay, on B?
Yeah.
Okay.
Are we gonna go over it?
Oh, you asked about the window for B? So what is your question here?
I'm just not sure what to do after what I just did.
Okay. Okay, let me come over here and take a look. Also, you guys got this, you want to do the next thing after that, okay? Good. What you do is you're trying to predict. Yeah, so what I'm gonna do is show the option, you can trace, you go to table view. So tracing, one thing you can do is, you go to trace. What's on trace here, you're on the function, right? Shows you the function. You can actually just go over to it. Value. Yeah, you can just go where you are, look for the X value, use those functions.
So that's what I put here, next thing up?
Yeah, well, you're looking for the X value, you're looking for how fast you have to drive, I guess, for a certain mileage, right? Yeah. Anyway. So on the table here, what are they? What are the values?
It's 30,
30,
40,
40,
50,
50, 60, 70. And then over here, the respective mileage for each is what?
30, 34,
34,
33.5, 31.5, 29, 27.5.
Okay, and so basically, if we go up to 0 to 80 and maybe 0 to 40, so 0 to 80 and maybe by 0 to 40, that should get us the window we need, right? So we go here, and in the window, 0 to 80 and 0 to 40, and then we have the plot turned on. We should get rid of this equation. So we should get something like that, right? And then stat calc 4, right? So negative 0.175x plus 39.85, right? Is it 0.175x plus 39.85? Okay, so now we can go to the calculator. .175x. So we graph. So is that what kind of correlation is this? Negative, right? And we're interested in 20 miles per hour, is that it? So we have different ways we can do it. Steve-O had a good suggestion last time. Another way that I just talked about with Luke is you can go to trace. If you get to trace and go right up to the, once you see this equation up here, you can go over to x equals 20 or close to it. And this gets exactly there, right? So is this your answer? Was that our answer here? So 36.35. Miles per gallon, and that's going to be at 20 miles per hour. Now, does that make sense? Does a car's mileage go down as you drive faster? Is that a true real-world thing? In general, it is, above a certain speed. What do you think causes that mileage to go down as the car goes faster? What do you think? The car has to work harder, yeah. But the harder work should translate into more speed, right? And more distance. But what is it that slows things down as it goes faster? What is it? Does a car encounter more resistance the faster it goes? Yes or no? Yeah, it does. What makes the resistance more? The wind, the air, right? Because you have to fight more air molecules to go the same distance. So that's the main thing I can think of. And I've noticed my mileage in my car change a lot when I'm going with the wind or against the wind. And one thing about my car that's pretty good is it's a car that has a miles per hour gauge on it that you can see what the mileage is, and you can see it change all the time. So I can check. All right, is that all we have for B? Then the last one here is this one.
What was it says what? Viewing windows.
Yeah, viewing window. This is the viewing window I picked out. Now I don't know if that's what you had. You may not have necessarily had the same viewing window. You're just building a window for your own convenience.
I know it's called the view.
Victoria, you okay? All right. So we'll work this one out here.
Under the trend, Debbie, is that the y equals negative?
Yeah, the trend, what trend do you observe? I think you have a negative correlation, right? That'll be a negative correlation. And then you have your prediction here. All right. And then here we have Vern with his sports teams.
Scott, can you just edit? Like you already know said that you do, like you pick frames for each image?
Yeah, and one thing you can actually do for this, and you don't have to do this in the same order, and I want to show you that just for thoroughness. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have that here. And then, oops. What are the output values for this? At 5, 10, right? 5, 10,
21,
21,
24,
24,
28,
28,
36,
36,
33,
33,
21,
21,
27,
27,
40,
40,
46, 50,
50,
31, 38.
One thing you have to watch is that the columns match up. If they don't match up, has anybody tried it with the columns not matching up? You'll get a dimension mismatch error. So from right here, before you even set the window, now I can see that we're going to have like maybe 0 to 15 and maybe 0 to 60, something like that, right? But if you go right from here, you can get the you don't have to set the window first. So you can go to Stat Calc 4. So you have an equation already here, right? So 2.4, about 2.41x plus 11.2. So in the window here,
Why'd you do 41?
well, just a rounding to the 100th place, right? 1 would be the next rounding to 100th place. Or unless you want to go 2.409, right? Or 2.4088.
So why would you round the 0 and not round the 1 on the other one? Because you just wrote 11.2 and not 11.22.
Oh, really? Okay. Well, I could write 11.22 just as easily, right? But that would be like 10. That would be like two 10,000ths off. Okay, that'd be very small, the difference there. So again, I don't have the best, like before, I don't have the best answer for you, but it's the same thing. It's a judgment. It's your judgment, and as a mathematician, you'll be able to make those judgments. So 0 to 15, and then what do you have? 0 to what's the highest thing they had there? Was it 50? So I'll go to 60. So go to 60, and we're going by 10 here. X scale, I'm going to go here to 1. And so now we have the graph. So now we have a window, but that's the wrong equation, right? So let's get the right equation, which is the one I have written down is this one right here, right? 2.41x plus 11.2. And so we graph this. Does that look like a pretty good line of fit? Yeah, that's pretty good. I mean, right in the middle, kind of. And not the tightest correlation, but we're just trying to predict. And what do we want to predict for on this one? 15. So right up here, so we might be able to see that almost, right? These are how far apart? These are what, 10 apart?
No,
1,
one.
1, 2, 3, 4. What is Y scale here? 10, right? So these are 10 apart. 10, 20, 30, 40. So it's going to be like 40, what? 47? 47.85? 0.35.
Would that one like always be different depending on like your maximum?
Yeah, I mean, it could be, yeah.
Because mine is 47.45.
47.45?
Yeah.
Yeah, what it is probably it's
Because
a,
I put 20 instead of, you put 15, I think?
Oh, did I?
20. Where am I? Hang on, windows.
on the window.
Yeah, I put 20.
Oh, here, 20? Yeah, 20. You could do that. That gives you a little more leeway for your prediction. But then we have this thing, we can go to second table and we can just enter, what was it, 15?
Yeah.
So 47.35. So 47.35.
How do you get to that thing? The thing that you just left?
Second graph.
Second graph. There's graph, and there's second graph.
15.
So anyway, ladies and gentlemen, I hope you feel like you learned something today. Did you feel like you learned something today?
What you